The Dyson Sphere. Picture a civilization that looks at its own star and decides it isn't bright enough. Not because the star is weak, but because they want all of it. Every photon, every ounce of power pouring into space. This idea was first imagined in 1960 by physicist Freeman Dyson, not as science fiction, but as a serious thought experiment. A way to ask a dangerous question: what would technology look like if a civilization never stopped advancing? A true Dyson sphere would be almost unthinkable. A massive shell completely surrounding a star, drinking in its entire energy output. No sunlight escapes, no radiation wasted, just total control over a stellar engine. But the engineering problems are nightmarish. You'd need more raw material than exists in most planetary systems. Gravity would pull the structure apart. One failure, one crack, and the result could be catastrophic, turning a star-sized machine into a storm of molten debris. So most scientists believe a smarter version would emerge instead. A Dyson swarm. Imagine trillions of artificial satellites orbiting a star in tight formation, each one collecting energy, each one transmitting power back to an unseen hub. Not a solid shell, but a living, moving cloud of machines, like a cosmic hive built around fire. The scale is almost impossible to visualize. Trillions of coordinated objects. Perfect timing. Zero margin for error. A power grid the size of an entire solar system. And here's where it gets unsettling. We might actually be able to detect one. A star wrapped in energy collectors wouldn't shine normally. It would appear strangely dim in visible light, but it would glow intensely in infrared, radiating waste heat from massive computation and industry. So if astronomers ever spot a star that looks wrong, dark where it should shine, hot where it shouldn't be, that wouldn't just be unusual. It would be like discovering a perfectly trimmed lawn deep inside a primeval jungle. Order, intention, intelligence. And if something out there can build a machine around a star, what else might it be capable of building next? The Ringworld. Imagine real estate so vast that planets feel cramped by comparison. If a Dyson structure is about power, a ring world is about living space, on a scale that borders on absurd. The concept was made famous by science fiction writer Larry Niven, but the idea itself is grounded in real physics. A colossal ring built around a star, with its inner surface engineered to be habitable, not orbiting a planet, orbiting the sun itself. Picture a band of land millions of miles wide, spinning just fast enough to create artificial gravity. Above you, the star never rises or sets. It simply hangs there, fixed, eternal, blindingly bright. There is no horizon of sky. The world curves upward, arching over itself until land meets sky in a seamless loop. This wouldn't be a space station. It would be a world. The surface area alone would dwarf Earth beyond comprehension, millions of times larger. Entire oceans could stretch endlessly. Mountain chains could run for tens of thousands of miles. Continents wouldn't be separated by borders, just by choice. To build it, a civilization would have to tear apart planets, strip moons down to their cores, melt asteroids into raw material, and then shape all of it using materials strong enough to resist tearing itself apart while spinning at unimaginable speed. That level of engineering doesn't just push limits, it rewrites them. But the brilliance of a ring world isn't just its size, it's its efficiency. Every square mile can be designed to be livable. No frozen poles, no uninhabitable deserts unless you want them. A single structure could host trillions of beings, entire biospheres, even preserved wilderness zones larger than gas giants. This isn't a civilization searching for a new home. It's a civilization designing paradise from scratch. Of course, perfection has a price. There's no natural day or night unless massive shadow panels are installed between the ring and the star. Weather systems would need constant control, and one serious impact, one destabilizing strike, could doom the entire structure, sending an entire world spiraling into fire. But for a species capable of building around a star, those risks might feel acceptable. And if something out there can build a world that wraps completely around its sun, the question becomes unavoidable. What other impossible habitats might already be hiding in the darkness? The Alderson Disc. This is what happens when restraint disappears entirely. When a civilization looks at a Ringworld and a Dyson structure and decides they're still thinking too small. An Alderson Disc is not a ring, not a sphere, but a colossal, flat disk with a star blazing through a hole at its center. Picture a cosmic platter trillions of miles wide, with a sun piercing it like a burning eye. The habitable region wouldn't sit at the edge. It would exist as a vast circular band on the disk's surface, neither too close to the star nor too far away. A narrow zone, relatively speaking, but still larger than anything we can truly imagine. The scale is absurd, and that's the point. Day and night wouldn't follow a normal cycle. Instead, they depend on the star's subtle up and down motion within the central opening. As the sun shifts, light sweeps across the surface in slow, dramatic waves, turning continents from blazing daylight to endless dusk. Closer to the center, the heat would be unbearable, a scorched, eternal desert under constant radiation. Farther out, the light fades. Temperatures plunge. Ice dominates. Between those extremes lies a band of perfection, a temperate ring of land stretching for unimaginable distances. Earth-like, stable, vast enough to hold oceans, forests, cities, and entire civilizations without ever touching the edge of the world. But gravity here would be wrong. You wouldn't just feel pulled downward. You'd also feel a constant sideways tug toward the star at the center. Level ground would be an illusion. Oceans would drift in strange currents. Mountains would need precise engineering just to remain standing under forces pulling at them from impossible angles. So why build something this unstable, this excessive? Because of one thing: surface area. An Alderson disk offers more living space than a ring world by orders of magnitude. Enough to make entire planetary systems feel like wasted space. A single structure that replaces every planet, moon, and orbit with one continuous expanse of habitation. A civilization that builds an Alderson disk isn't just growing. It's rewriting the idea of existence itself. At that point, a home planet becomes a forgotten concept. Space stops being something you travel through and becomes something you pave over. And if something out there has already turned an entire solar system into one colossal world, how would we even recognize the remains of such ambition from light years away? The Matrioshka Brain. What if a civilization's endgame isn't conquest or colonization, but thinking? What if its greatest ambition is not to spread across the stars, but to understand them perfectly? That question leads to one of the most unsettling megastructures ever imagined. Not a habitat, not a power plant, but a mind on a stellar scale. The Matrioshka Brain gets its name from Russian nesting dolls, and the design follows the same logic. Layer after layer, structure inside structure, each one wrapped around a star, each one feeding on the energy or the waste heat of the layer beneath it. At the core, a Dyson-like shell runs at blistering temperatures, performing calculations at unimaginable speed. Raw processing power beyond anything we can conceive. Surrounding it, another shell captures the discarded heat and uses it to run its own computations. Slower, cooler, but still vastly superior to anything humanity has ever built. Then another, and another, each layer cooler than the last, stretching outward until the final shell radiates energy just barely above absolute zero. Nothing is wasted, not a single joule. The result is a computational engine so powerful it stops feeling like a machine. A fully developed Matryoshka brain could simulate entire galaxies, run countless artificial civilizations, explore mathematics so deep and abstract that human language wouldn't even have words for it. This wouldn't be technology. It would be cognition itself, scaled to a star. A civilization capable of building such a structure might no longer live in physical bodies at all. Its population could exist as digital minds, uploaded into this vast system, experiencing customized realities indistinguishable from paradise. Or perhaps the builders were never biological to begin with. Machine intelligences that view the universe not as a home, but as a data set, something to be analyzed, modeled, and solved. And here's the most disturbing part. Detecting a Matrioshka brain would be almost impossible. Like a Dyson structure, it would appear dark in visible light. But its infrared emissions would be faint, barely warmer than the cosmic background itself. A silent intellect, a thinking star, hiding in plain sight. If something like this already exists, quietly calculating at the edge of our detection limits, how would we ever know we're being observed by a mind older and larger than our entire civilization? The stellar engine. Why travel between stars when you can move the star itself? That's the staggering idea behind a stellar engine, a machine built not to cross space, but to drag an entire solar system with it. This isn't spaceflight as we understand it. This is celestial migration, a civilization packing up its sun, its planets, and everything it has ever known, and setting off across the galaxy. Several theoretical designs exist, and none of them are modest. One of the most famous is the Shkadov thruster. Imagine placing a colossal mirror beside a star, angled just right. The star's own light pushes against it, creating a tiny but relentless force. Minuscule thrust, but applied continuously for millions of years. Slowly, patiently, the entire system begins to drift. Its travel measured not in years, but in epochs. A method built for species that think on planetary timescales. Then there are more aggressive designs, ones that border on reckless. In these concepts, vast amounts of hydrogen and helium are siphoned directly from the star and fed into a titanic fusion engine. The resulting plasma is expelled in a focused jet, pushing the entire star forward like a cosmic rocket. It's vastly more powerful and vastly more dangerous. One mistake, one imbalance, and the star could destabilize, flicker, or erupt catastrophically, turning the engine and everything around it into a stellar catastrophe. So why take the risk? A civilization that builds a stellar engine isn't improvising. It has a destination. Perhaps it's fleeing a region of space doomed by cosmic decay. Or maybe it's embarking on a journey so long that no individual will ever see the end, only the continuation. This is the ultimate expression of patience. A species willing to wait millions of years to reach its goal. And if astronomers ever discover a star moving in a way that defies gravity, drifting with intention rather than chance, it would be like finding tire tracks in the void. Proof that somewhere out there, someone isn't just exploring the universe. They're driving it. The Shkadov thruster. Let's zoom in on one stellar engine in particular, because this one is too elegant to rush past. The Shkadov thruster isn't about brute force or explosive power. It's about finesse, about using a star's own light against itself. Named after astrophysicist Leonid Shkadov, this design is almost poetic in its simplicity. No engines, no fuel tanks, just light, gravity, and patience. Picture a vast, curved mirror hovering near a star, not orbiting in the usual way, but held in place by radiation pressure itself. This structure is known as a statite, a static satellite that balances perfectly between the star's gravity pulling it inward and the star's light pushing it away. The mirror sits above one of the star's poles, forming a gigantic reflective arc larger than worlds, bigger than imagination. Now watch what happens. Photons pour out from the star and slam into the mirror. They bounce back, transferring momentum in the process. That tiny push is enough to hold the mirror steady. But something else happens too. By reflecting a massive portion of the star's light in one direction, the system creates an imbalance. The star is no longer radiating evenly into space, and that imbalance becomes thrust. The star, quite literally, begins to push itself, using its own radiation as propulsion. No flames, no roar, just a continuous, invisible nudge. The force is unbelievably small, but it never stops. And given enough time, millions of years, the motion becomes undeniable. The entire solar system begins to drift. Slowly, deliberately. This is cosmic martial arts. A civilization redirecting stellar forces with surgical precision. And if astronomers ever notice a star whose light is oddly asymmetrical, whose motion doesn't quite match its neighbors, it might not be a natural anomaly at all. It might be evidence that someone, somewhere, learned how to steer a sun and is already on the move. The Bishop Ring. If a ring world is a galaxy-spanning empire, the Bishop Ring is something more personal, smaller, intentional, a world designed not for domination, but for living. The concept was proposed by engineer Forrest Bishop, and unlike many alien megastructures, this one sits right on the edge of what physics actually allows. It's still enormous by human standards, just not absurd by cosmic ones. Picture a massive rotating ring, shaped like a smooth, hollow torus, about 1,000 kilometers in radius, spinning just fast enough to create comfortable, Earth-like gravity along its inner surface. The structure would be built from materials like carbon nanotubes, strong enough to hold itself together under constant rotation. Inside, there's atmosphere, weather, oceans, an entire ecosystem sealed within a curved horizon. And here's the key difference. A Bishop Ring doesn't need a star at its center. It can exist almost anywhere, drifting through deep space, orbiting a planet, parked far from danger, completely off the grid. It's a self-contained world you can place wherever you want. That practicality is what makes it remarkable. With enough time, enough resources, and enough patience, a civilization like ours could theoretically build one. Not tomorrow, not next century, but within the realm of possibility. Think of it as a starter megastructure, the first real step toward artificial worlds. And don't let the word modest fool you. One Bishop Ring could offer thousands of square miles of livable surface, room for cities, forests, and millions of inhabitants. And because they're independent, they can be built in groups, clusters, networks, entire chains of rotating habitats. Not one world, but many. A future where civilizations aren't tied to a single planet, but grow outward by constructing homes wherever they choose. World by world, ring by ring. And if space is already dotted with structures like these, quietly rotating in the dark, how many artificial neighborhoods might we be mistaking for empty sky? Orbital rings. Reaching space is brutal. Every launch fights gravity, burning fuel, burning time, burning resources. But imagine a shortcut, a cosmic highway that makes the sky feel like just another neighborhood. That's the promise of an orbital ring. A spinning band encircling a planet, rotating slightly faster than orbital speed, constantly trying to fling itself into space. And yet, it stays put. Tethers anchored to the surface hold it steady, balancing centrifugal force with gravity in a delicate, unbroken dance. The result? A structure that hovers above the planet, stable, stationary, impossible to ignore. From this ring, spokes could reach down like giant bridges. Magnetic elevators zipping up and down, carrying people and materials from the surface to the ring in mere hours. No rockets, no perilous launches, just smooth, effortless travel. The ring itself could host entire cities. Habitats with sunlight streaming in, panoramic views of the planet below, and infrastructure for billions to live, work, and travel. A single orbital ring would transform a world into a hub for the entire solar system. The engineering challenges are immense. Material requirements beyond anything humanity has ever produced. Tolerances tighter than any bridge or skyscraper. But unlike a Dyson Sphere or Ringworld, an orbital ring sits squarely within the realm of theoretical possibility. With enough resources, time, and ingenuity, it could be built. It's the ultimate frontier infrastructure, a bridge to space that doesn't just reach the sky, it becomes the sky. And if alien civilizations are already building such rings around their planets, orbiting quietly in plain sight, what kind of future might they be preparing while we're still learning to lift off the ground? The Topopolises. Take the idea of a rotating habitat and stretch it until your mind starts to hurt. That's the Topopolis, a thin, tubular world looping around a star again and again, like a strand of cosmic spaghetti. The tube spins, generating artificial gravity along its interior. Step inside, and you'd find a landscape that feels endless. Walk straight for centuries, and you still wouldn't reach the edge. Cities, forests, oceans, all seamlessly curving above and below you. The sky formed by the opposite side of the tube. The star itself appears as a distant, brilliant point of light. Its position shifts depending on which loop of the tube you inhabit, creating a surreal rhythm of day and night unlike anything on a planet. It's a structure that seems impossible, absurd, defying all intuition about worlds and gravity. And yet, it has one extraordinary advantage: stability. Unlike a fragile ring world, the Topopolis holds itself together through internal tension. Its own shape, stretched and spun, gives it resilience against the stresses of orbit, rotation, and cosmic hazards. A megastructure designed to endure. A civilization capable of building a Topopolis is one that prizes patience and longevity above all. They think in millennia, not years. They craft homes that will last for eons. It's a world designed not for speed, not for conquest, but for permanence. A ribbon of life, spinning eternally around a star, stretching the very definition of what it means to call a place home. And if such structures already exist somewhere in the galaxy, quietly looping through the void, could we even recognize them for what they truly are, or would we just see a strange glimmer against the stars? The Kardashev scale, not a structure, not a machine, but a way of measuring the ambition of civilizations. A cosmic ruler, stretching from fledgling planetary societies to beings so powerful they could reshape entire galaxies. Proposed in 1964 by Soviet astronomer Nikolai Kardashev, the scale ranks civilizations by the energy they can control. It's a ladder to the stars. Type 1 is planetary, a civilization that has mastered all the energy available on its home world, controlling weather, geology, even life itself. Full command over a single planet. Humanity? We're still crawling at around 0.7 decades or centuries away from that milestone. Type 2 is stellar, harnessing the power of an entire star. This is where Dyson Spheres, Ringworlds, and Matrioshka Brains come into play. A civilization capable of reshaping its solar system, bending planets, stars, and energy to its will. Type 3 is galactic, controlling billions of stars, weaving structures across entire galaxies, building megastructures so vast they make entire solar systems look like toys. A civilization so powerful it might manipulate space-time itself. Essentially godlike. The Kardashev scale is humbling. It's a reminder of how far we have to go. Yet it's also electrifying. A roadmap, a challenge, a cosmic dare to push beyond our tiny, fragile world. It asks one simple, terrifying question. If intelligent life can climb these steps, are there already beings out there who have reached the top? And if they have, what would their megastructures look like? And could we even recognize them in plain sight? If the universe can hold wonders this unimaginable, why stay grounded in the ordinary? Dive deeper into the mysteries hiding in plain sight. Subscribe to Strange Wise and join us on a journey through the cosmos, where every star, every shadow, and every megastructure tells a story that will challenge everything you thought you knew. Don't just wonder, explore. Don't just watch, question. Click that subscribe button, turn on notifications, and step into the strange. The universe isn't waiting, and neither should you.